Hello and welcome to Tech Lessons with Alvin. Now I'm really pumped for today's class. I won't lie to you. There's so much energy here because let me give you a little history. This is a topic that had me staring at the teacher in class like, yo, what are you saying? And I left the class believing this is a topic I'll never understand. I'll understand other topics in networking, cool. But when it comes to subnetting, this will be my Achilles heel. Like, nah, I don't think I'll ever get this. But to think I get it now, yo, I'm really hoping there's someone out there like me who believes Charlie subnet's in the air now. Or probably you don't even know what it is and you have low expectations for yourself. Like, this one there, I just go watch, but I don't go understand. Opana, you understand. It's no overconfidence, but then with how simple the explanation is, I really truly hope that you understand. So without any further ado, let's get into it. Now, before we start, subnetting, of course, it's under networking. If you separate it into two, you get sub and netting. Sub as in submarine, underwater. Subnetting, it's under networking. You try to divide or find other networks from a main network. So I'll write something here and you don't really need to understand it, just need to look at it, and in the next video, which is the last video, you'll smile when you see it, like okay, I get this. So what we're looking at here is 192.168.4.0, and then we put something here, a slash and a 24. What is this? Now before we continue, this is not your basic mathematics, right? We are trying to divide this into other networks, cool, but we don't go ahead and use something like this divided by, let's say we want 4 networks, then we put 4 networks here. If you put this in your calculator, decimal is supposed to be just 1 decimal point, but now you have pa. That tells you these are not decimal points, right? So what are we dealing with? If you can't divide it like basic arithmetic, how can you work your way around it then? Good question. Before I get to it, let's warm up. Let's warm up. I want you to think of this as bread. Now, don't leave. Please don't leave. I'm not joking. Really, think about bread. A nice, fresh loaf of bread. Now, in the olden days, if you wanted bread, here in Ghana, if you wanted to buy bread, you had to buy a loaf of bread. Even if what you needed was just a few slices, you buy the whole loaf, you take it home, you eat your few slices. If you are not fortunate and it spoils, well, you have to throw the rest of the bread away, right? But then something amazing was invented, something called sliced bread. Wow. I don't know if you noticed, now you go to the mall and stuff and then the bread is already sliced. It's so cool, isn't it? But then with networking, you, the network engineer, have to slice the bread yourself. That's subnetting. Now, picture this. You were able to get out of every loaf of bread exactly 32 slices. Now, why 32? We'll get to that in a bit. But you're able to get 32 slices. So someone comes and like, Charlie, I'll buy bread and give me some 4 cedis. You can gauge, okay, this 4 cedis give you about maybe 8 slices of bread, right? And so on and so forth. But as a rule of thumb, I don't know if that's even correct English. Generally, no one will sell the ends of the bread to you, right? It's not cool. It's not cool. Let's say you go and you just want 1 slice. They are obligated. It's an unspoken rule. They have to cut the slice from the middle and give you that fresh portion, not the end, not the butt of the bread. It's not cool. So why all this? Why bread? Good. Let me clear this a bit. Hold on. Cool. Now, the ends I mentioned earlier, right? Think of them as Bad handwriting. But what I'm trying to write is, think of this end as the broadcast ID and think of this side, I'm shortening it to N/W. That stands for network ID. Why network ID and broadcast ID? Because these two are not assigned to the host, right? The host will not have a broadcast ID or a network ID to have an address from this portion of the network, always, at all times. So when we get to solving, we'll find out what the network ID is and what the broadcast ID is. So because these two are not assigned to the host, what you normally do is, let's see, when you get your full number of number of IP addresses, let's say you get a number like 256, automatically you have to take away 2. So what you actually have to give to your hosts is 256 minus 2, which gives you 254. Now these are the assignable IP addresses. It goes on. If you have 32, you take away 2, you are able to give only 30 out. The other 2, like these parts of the bread, are not for the host. They are known as the broadcast and the network ID. Now, why the number 32? We've seen 32 here. Why is 32 here? Let me clear this a bit. Give me some time. Okay, I think we're good now. Now you have, get this out of the way. Get this, we don't need this. Now, it's 32 because of something special. Now this right here translates into bits. Bits. You may have heard of them before. Now some of you don't get bored, especially if you have some background in IT, right? It's always good to go back to our basics. Binary refers to numbers in ones and zeros, right? So what you're looking at here is just the number 2 in binary, right? Now, the number of bits in an IP address is the same as the number of slices in the bread here. It's 32. What this means is, if you divide these into 4, what you get here is 8 bits plus 8 bits plus 8 bits plus 8 bits. That's 8 times 4, 32 bits. Wow. Now we're getting closer to something. Now, how do we represent this as bits? Let me clear some space here so we get some work done. So now we have that information. Now you know this is 8, this is 8 bits, 8 bits, 8 bits. Okay, I'm looking at 32 bits. Now what is this? What is this? What is this /24? Excellent question. Now we need something known as the subnet mask to be able to divide this. Oh my god, I'm trying to draw an arrow, it's not working out. Anyway, to divide this into an address. So simply, what this 24 is telling you is you have 24 bits on, right? And 32 minus 24 is what? 8. So what that means is this last segment is untouched. So how will you represent this? Since it's a subnet, first 255 dot 255 dot 255 dot 0. 8 bits full, 8 bits full, 8 bits full, summing up to 24. Now this is where the subnetting takes place, right? This is what you really have to work with, right? Good. So what we need to know is, let me just give you a graphical representation, right? So if we are talking about 8 bits, this is it. 1 2 3 4 5 6 7 8. You put your dot here. 1, 2, 3, 4, 5, 6, 7, 8. You put your dot here. 1, 2, 3, 4, 5, 6, 7, 8. Put your dot here. Then you do 0, 0, 0, 0, 4, 0, 0, 0, 0. This is it. This is it. It's just 24 ones and 8 zeros. This is where the subnetting takes place. So now you may be wondering, how many IP addresses can I get? How many IP addresses? Right, 192.168.4.0, and I have this /24 here. Okay, it's telling me that 24 bits are on, right? That means I have 24 ones. And then I have 8 zeros at the far right side, at the ending. Okay, I get this. And the total is supposed to be 32 bits. That's how come I have 8. 32 minus 4, 24. That's 8. Cool. So what next? What really does this mean? How many IP addresses will I have? Can I address to my client? Is it 8? Well, to get there, we need to do one more thing. Now, this is basic probability, right? Now, the reason I said this is basic probability, we'll find out right now. You have 1, 2, 3, 4, 5, 6, 7, 8. You have 8 bits. Now I've not put any ones or zeros here yet. There's something important we need to know about these 8 bits. Before I put the numbers under them, I need to let you know how we are getting those numbers. Now watch this space. I'll put a formula here, and by the time that formula enters this box, you'll understand what it means, what it does, how it works, and how you can use it. So, you've played the game before. Now, what game is this? You have a coin in one hand, right? Now, let's say instead of using normally your 2 fists to play this game, you decide to use just 1 fist, right? In so doing, the coin is either in the hand or it's not in the hand. It's that simple, right? What if you now use 2 hands, right? 2 hands, maybe this time 2 coins, but you get to choose how you put the coins in. Now the possibilities become like this. It's either the coin is in one hand and not in the other, which in this case the coin is in your left hand and not in your right hand, or the coin is in your right hand and not in your left hand, or you have 2 coins in both hands, or there's no coin in either of your hands. Now you up it a bit to 3 coins. So in a sense, there's a third person, there's another person, right? So he just adds his fist. So now you have 3 fists looking at you. Now you have to choose which one has the coin, which one has the coin. It could be that all 3 have the coin, it could be that none of them have the coin. So how do you represent this as well? Now it's either, now I'll mess up this a bit. It's either none of them have the coin, or it's not in the first guy's hand, but the new guy's hand, it's inside there somewhere, or it's not in this hand, but it's in this hand, and it's not in this hand, or it's not in this hand, but there are 2 coins here, or it's in this hand, but it's not here, and it's not here, or it's here, but it's not here, and another one is here. Oh, it's here, but it's not here. Ah! You have all 3 coins in all 3 hands. Now, if you look carefully at it, you realize these are the only possibilities. There are no other possibilities, right? So, what are we looking at? So, when we had 2 hands here, how many possibilities did we have? 4. When we moved on to 3 hands, how many? 1, 2, 3, 4, 5, 6, 7, 8. And when we had just 1 hand, we had 2. Now, are you noticing how it increases from 2 to 4 to 8? So the next one, can you guess? If your guess is it's like mine, then you have 16. You could take your time and then write it out 0, 0, 0, 0, 0, 0, 0, 1 in that order, and keep trying to exhaust all the possible options, and you realize that you have 16 of those possible options. Then if you move on to even trying 5 different combinations, you realize the 16 becomes 32, and it keeps increasing, it keeps growing. So now this is the formula. You have 2 to the power x. Get this right. Where x here simply refers to the number of, well, I almost said the number of hands, but we are dealing with networking. So the number of bits, right? So as a rule of thumb, we start counting from 0, right? So it's 0 to 7. So now with that analogy, analogy in mind, this x here just represents one of these bits, right? One of these bits. So let's put 2 to the power 0 here. We start counting from 0, right? Then we move on to 2 to the power 1, 2 to the power 2, 2 to the power 3. Sorry, my stylus pen is not really that good. 2 to the power 4, 2 to the power 5, 2 to the power 6, then 2 to the power 7. Now 2 to the power 0, we have a 1. To the power 1 is the same as 2. To the power 2 gives us a 4. To the power 3, an 8. And we keep going, 16. And we keep going, 32. And we keep going, 64. And we keep going, 128. Wow. And you realize, if you add up everything, all the numbers here from 122 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, you get 255. Now, I hope it's all connecting to you. It's all oh, okay, he wrote a subnet mask. Okay, he said that the /24 means 24 bits are on. Then he proceeded to draw 8 ones, 0.8 ones, 0.81, 0.8 zeros. Then he said when all the ones are full, it's 255.255.255.0. So okay, this 255 just means everything here is on. That's cool, isn't it? So now let me clear these ones. Now we get something. Now let's look at this number 192. How can we represent 192 as binary using these 8 dashes we have here? What do? Now we need to find out the exact combination of numbers here that when added together will give us 192. And when we do find them, we have to represent them as ones, and the rest becomes zeros, right? So let's try out. Now 182. Hey, wow, 128. 128 plus, let's see the next number, 64. I wish I could do something rough here, represent it so we all see. 128 plus 64 gives us, you have 12 here, 6, 7, 8, 9, and then a 1. That's exactly the number we're looking for. What this means is 128, this is the spot, you turn it on. 64, you turn it on. Now these are the only two we need to get 192. The rest, 0, 0. It's not good, 0. Oh my, I don't like the zeros. Anyway, 0, 0, 0, 0, 0, 0. So what does this mean? This just means 192 in binary is 11000000. Now we can try the same for 168 and 4. 4 will be easy because you just take the 4 here as on, just put the 1 here, and then everything else is 0. That's for the 4, right? And that's it. That's it. Now, how do we actually get the IP addresses? Before that will be in the next video. So what have we learned? Looking at this, we have learned that this /24 here means 24 bits are turned on. Now, this also tells us that the total, which is 32, minus this 24 gives us an 8. And what this 8 simply means is in the last octet, we have 8 zeros, right? And everything else is a 1, right? Don't worry to count them. They may not be accurate, but you get the idea. So now we know how to represent this here. And even before this, what this also tells us, just looking at this, we are now experts. We are now experts. So what this also tells us is, /24. Okay, that means this side, yeah, this is what I'm dealing with. So the rest of them, I represent them as 255.255.255.0. It also tells us the subnet mask. So we can get the subnet mask, and the representation of that subnet mask in binary. We can also now convert this exact IP address to binary. And in addition to that, we know how to convert it to binary using our formula 2 to the power x. What that simply means is 1, 2, 3, 4, 5, 6, each of 7, 8. Starting from the far right, you have the number 1, next is 2, then 4, then 8, then 16, 32, 64, and then 1, 2, 8. So with this model, we can now translate any number we see in any of these octets to binary, right? So now we have this idea, we understand what to do with the IP addresses. And what else do we know? This 11111, these 8 ones simply tell us 255 possible IP addresses can be assigned, right? And if you remember the bread illustration, we'll get to that in a bit. You get that, pun intended, in a bit. Anyway, with that, let me quickly chip this in. It's like how the clock works, okay? When it goes from 2:59, it doesn't go to 2:60, right? From 2:59, it goes to 3 o'clock. Same way, especially in an IP address, the 192.168.4.256. What? No, it ends at 255, doesn't it? It does. What this simply means is it becomes 0, and just like in 259, the 2 now becomes 3, Once this becomes 0, you change what you have here to a 5, and it becomes 192.168.5.0. It's just like the concept of time, right? So out of the 255 possible IP addresses we can get from this particular example, we can only make use of 253. We took away 2. Now if you remember the bread illustration, the ends are not needed. The front and the back, those 2 slices, those 2, where can I draw bread? Let me take the top right corner, right? Yeah, it's a very small loaf of bread, but the point is, this and this part, people don't normally eat it, right? So you cut it off. So that's the same kind of mathematics we do here. We take away the broadcast ID and the network ID. That's why we take 2 away from the possible IP addresses. Now, I really hope you understand. I really hope you understand. I really hope you. If you understand, it will make me so happy. It will make me so happy. Really, I'll be really happy if you understand. But then, in the next lesson, I'll try to refresh what we did in a minute or less. It seems I talk a lot. In a minute or less. And then we move on to the actual stuff. Subnetting in its final form. So, it's been Tech Lessons with Alvin. This has been Subnetting Part 1. And I hope to see you in Subnetting Part 2. Have a great day.